let's look at the survivorship curves. Okay, so for the population, it is not important which members die, but for it should be which members survive. Okay, we should try to plot these curves so that we understand how or what are the factors which cause the members to die. Okay, so thus we have to plot the survival rate. Okay, so the survival rates are as much interest than the death rate. Therefore, we have to plot survivorship curves. Okay, the pattern of mortality with age is best shown in the case here. Okay, the pattern of mortality with age is best shown by survivorship curves which plot the members surviving to a particular age. Okay, well, survivorship curves, they show us a graphical representation of how many numbers survive at a particular age. Okay, so there are three types of survivorship curves. Let's look at them. The first type is the high convex curve, that is, I will show you. Then the second one is concave curve, and the third is diagonal curve. I'll just show you just a glance and I'll explain nicely. You see, one is diagonal, one is concave, one is convex. Okay, so let's look at them in detail. Now, in the figure, we will see that one of the curve is a convex curve. Okay, it is characteristic of the species in which the death of the population is low until near the end of the lifespan. Okay, so these species tend to live throughout their lifespan, and they don't die at the young age, they will die lower. Okay, so humans, we show this sort of curve. Animals, bigger animals like deer, like sheep, like buffalo, cow, you know, some species, some very few dogs and cats also that, you know, you've heard, no, cats that live for 7 years, 8 years, 10 years, right? So let us just look at the first curve, that is the curve A, the survivorship curve. Okay, if I do this way, how do I make? Okay, I made it small. Okay, now, okay, this is the survivorship curve. Here in the x-axis, we will plot age, okay, or the percentage of the life. So with age, then here, let's see, if it's a man, this is at 1 year, 2 years, 3 years, and here maximum will be at maybe 99 years old. Okay, all right, so you can see, okay, the man at 1 year, 2 year, 3 years, he is very strong. Okay, then maybe here he's reached maybe how many, let's say 60 years or 70 years, like that, he starts to die off, right? He starts to die off. Okay, so I think you understand, no? Here, when he's young, as a toddler or a teen, his survivorship is very strong. Okay, it's like most of those. See, out of this is number of individuals. Okay, this is 1 person, 10 person, 100 person. This is 1,000 person. Okay, because usually we express in the terms of per 1,000 individuals. So if there are 1,000 children born at this time, and 1,000 of them will survive, okay, maybe then few will die off, maybe 1 or 2. You can start seeing. Okay, then as they reach 70 years of age, they start dying slowly till maybe 1 person will live up to 100 or 120 years. Okay, so it's easy enough. Let's look at the next curve, that is your high concave curve. Okay, here the death rate is high during the young stages. This is seen in animals that produce lots of children, like eggs, larvae of fish, no? Like if some of you have seen your mother cutting fish, no? You will see fish eggs, so many. But out of those 1,000 fish eggs, maybe 100 will survive. You understand? So these are the characteristics of those animals that produce so many youngs. Okay, just like what to say, those spores of the pine, no, those pollen, so many are released, no, but very few will germinate into a big type of plant. Let's look at the curve, the concave curve. Okay, this curve is the highly concave curve. Okay, I'll just minimize it. This is the concave curve. All right, so they produce in one go, no, they will be producing 1000 individuals, and out of the 1000 suddenly it will drop. See, it will drop. Okay, see, they started with so many, with 1000, then out of 1000 only 100 have survived. Okay, at maybe 1 year. Then out of those 100 again, at 2 years only 10 survive. Okay, then again, then let's say maybe at 10 years only one will survive. Okay, I think it's easy enough. Now let's look at the diagonal curve. Here the age specific survival is more or less constant. The curve appears like a straight line. Okay, it shows constant proportion, means with time they will constantly survive, constantly will die over time, constantly. Okay, so no population in real life dies constantly. No, it's not like out of 1000 birds in 1 second one has died, another one born. Okay, and then in after 10 seconds 10 died, another 10 born. That is not practical, no. However, we can see some sort of similarity to that diagonal curve. Not exactly similar, but like this. Okay, very close to the diagonal curve. Let's say if this is a diagonal curve, it might go like this. Okay, it's not exactly concave nor is it convex, but it somehow follows the slightly concave, slightly convex, but not exactly perfectly diagonal. Okay, so let me read again. Diagonal curve, it is the age specific survival more or less is constant. The curve approaches a diagonal straight line as shown in the curve B2. Let's see. So in B2, you can see that there's a straight line, okay, which is not possible in theory. I mean practically. But we can see a slightly concave or convex or sigmoid curve B3 in the figure, where it occurs in nature, that we find in many birds, mice and rabbits, okay, as well as those insects which complete their metamorphosis, such as butterflies, etc. Okay, so let me just explain simply, you'll understand. So these butterflies and homo, what is that? I forgot the word. Homo something. Tabolus. It's holometabolous insects. Holometabolous insects. Okay, so here so many caterpillar eggs were produced. Okay, 1000 caterpillar eggs were produced. Then suddenly they died and 100 or so is left. Okay, then they survive, those 100. Out of 1000, only 100 survive. Then out of those 100, they will cocoon themselves, right? Then during the cocooning part, some will die off. So you see it's coming down. Then as they emerge from the cocoon, some of them, their wings are not so strongly formed. Okay, then those with the weak wings, they start dying off again. All right, they start dying off. Some of them, they already died here during the cocooning part. You know, somebody crushed it, an animal ate it, you know. we foraged it in the forest. Okay, so they died off. Then those few who had the strong wings, they came out of the cocoon and they survived. And then some of them again, they die off. They got eaten by insects, and then lastly, very few will survive up to their old age. The survivorship curve will never remain the same. It will change according to the environmental condition, the habitat, and other population interference. Okay. For instance, tropical birds will live longer than temperate ones because of the extreme cold. No, in temperate regions, the cold climate, it affects them. Okay. My goodness, how to close this?